We have another question which says, a crane drops a 0.3 kg steel ball onto a steel plate. So the ball's speed just before impact and after are 4.5 meters per second and 4.2 meters per second, respectively. So if the ball is in contact with the plate for 0.03 seconds, what is the magnitude of the average force that the ball exerts on the plate during impact? So this one is simple and straightforward. So what you just need to do on this question is to, we know when you're dealing with impact and momentum, the equation that joins the two is, okay, let me just say the change in momentum in terms of force. Or before we do that, first, let's take the data. Let's collect the data. So we have the data that we've been given here is, we've been given the mass of the ball. So the mass of the ball is simply just 0.3 kg. And the ball speed before and after impact. So we have before impact, the speed of the ball was, so V1 before impact was, so meaning, let me say the initial velocity, which is the velocity before impact was 4.5 meters per second. And then the final velocity, that is after impact or at impact, let me say during this period of time, which is 0.03 seconds, is simply just 4.2 meters per second, respectively. Okay, so if the ball is in contact with the plate for 0.03 seconds, so for them to tell us to say the ball was in contact for this period of time, it means that the ball at one point bounced back. And what it means that if what this means is that if the ball bounced back, the velocity, if the ball bounced back, it means that at one point the velocity was negative. So we take one of the velocities to be negative. Let's see what I'm talking about. Okay, so that's the meaning of that statement, to say if the ball was in contact with the plate for that period of time. So the question is asking, the question is asking us to find the magnitude of the average force the ball exerts on the plate during the impact. So, like I said, the formula the formula that joins momentum, the change in momentum with force, is simply just, we know to say the change in momentum is given by force times time. Of course, this time should also be the change in time. But because there was this aspect of the ball bouncing back, it's an assumption that we've made. We expect the change of momentum to be, so we're going to say F delta T will be equal to, so we're going to have, so we have the first momentum and the second momentum. So we say P minus, we say P, so we say P final minus P initial. So instead of having a minus there, we're going to have a plus. Yeah, we're going to have a plus. Like I said, one of these velocities is going to carry the negative sign. Okay. So what this simply means is that, okay, let me just write it this way. Maybe that's when you understand what I mean. So what I'm trying to say is this. We'll have the change of momentum. And okay, let me write the formula properly. We have force times change in T is equal to the change in momentum. So the force that we're looking for will be found by writing the change in momentum over the change in time. So the change in time has been given to be that. Now, let us find the change in time has been given. Let us find the change in the momentum. So this will therefore be equal to, mass times the change in velocity. and then everything over the change in time. Okay. So the force will therefore be given by, so the change in, the mass has been given to be 0.3, and then the change in the velocity is therefore going to be equal to 4.5 plus 4.2. And then everything will divide them by 0.03. So when you find the force there using a calculator, this will give you 0.3 times 4, that will be 8.7. So times 8.7, this will be 2.61 divided by 0.03. So you're getting 87 newtons as your final answer. So this is the answer for this question. It's also a very short question. Okay, so let's quickly move on to the other question. So I want us to cover as many questions as possible today. So, okay. So we move on to the next question. So I'm going to send the recordings immediately after the lesson is done.